Hello and welcome to another one of D's ADD videos. Today we're going to be looking at intermediate level polar graphs. So not too difficult, but a little bit more complex than your, just graphing your basics that we looked at in part 1. So here we have r equals 2 and theta equals negative 3 pi over 4. Let's look at r equals 2. r equals 2 is going to be a circle with a radius of 2, so that going out 1, 2, right here. Theta equals negative, so that was in yellow there, and then theta equals negative 3 pi over 4. It would go 3 pi over 4 is 45 degrees in the second quadrant if we were going positive. So if we're going in the negative direction, it would be 45 degrees in third quadrant there, and we can label it theta equals negative 3 pi over 4. Alright, from here to here. Alright, so let's move on. What if we had something like this? Well, that's not your typical everyday graph, so we got to do a little manipulation. So try to eliminate the parameter and see what it looks like in rectangular coordinates. If you can't, just mess with it in polar coordinates. It's not one of the basic ones we went over in the concept video, or you can't just do one of those basic things we just did. We can maybe convert this into r equals 3 over sine theta. Oops, sorry about that. And then multiply both sides by sine theta. And if you remember, this is one of the equations for polar coordinates. That's what y equals. So we have the line y equals 3. So if we were to plot that, 1, 2, 3, it would look something like this. It's a horizontal line at y equals 3. And then you can label it r equals 3 cosecant theta. Alright? The last example I'm going to show you is a rose petal. So rose petal is a little bit more in depth than these other guys. First thing you got to remember that this is going to be your diameter of the rose petal, or how long it's going to be. And then this is going to tell you how many petals. And if this number here is odd, then n equals the number. But if the number is even, then you have 2 times the number is our n. Okay? So in this case we have 3 petals, and it's the diameter of 4. So now what we got to do is we got to ask ourselves, what's the maximum value of sine? Sine's maximum value is 1 times 4 is a maximum radius or diameter of the petal of 4. So what we can do is we can set this whole function equal to 4. What you're doing there is you're asking yourself, at what theta values here does my radius equal 4? So when you solve, hopefully you don't run out of space like I just did, you put 4 divide both sides by 4. So then where does sine equal 1? Well, sine equals 1 oops, 1 comma 0, 0 comma 1. The first one's cosine, the second one is sine. So you could do that all the way around just for the main axes. So we have pi over 2. Now the problem is this is a 3 theta, so that means we have to go around 3 times. So we got to add 4 pi over 2, or 2 pi, to this. So if I add 2 pi to this, it's going to give me what? 5 pi over 2, and 9 pi over 2. This was my first revolution, my second revolution, and there's my third. And that equals 3 theta. Divide both sides. And now I have found where my petals are going to be. Now, quick side note. Had I only gotten 2 of the 3 petals, or 1 of the 3 petals, what I would have done then is set the whole function equal to -4. And then solve, because sine's minimal value is negative. 1 times 4 is a -4. And then you'd just be solving like we did here. But since I got all 3, I don't need to do that here. So the next thing is to find tangents at the pole. If you remember, the tangents at the pole are kind of like your asymptotes of the polar coordinate system. Everything's forced back into the center. Oops, not tangents of the pole. So, if I set the whole thing equal to 0, divide both sides by 4, where does sine equal to 0? If we come up here, that's going to occur at these 2 spots here, which is 0, pi, and 2 pi. But I got to go around 3 times again in the unit circle. So, 0, pi, 2 pi, there's first revolution. And then if I add pi, it's going to be 3 pi, 4 pi, there's the second revolution. And then add again 5 pi and 6 pi. And then all that is equal to 3 theta. So if I divide everybody by 3, now I have these tangents at the pole, where my polar function is forced back into the origin, or radius of 0. All saying the same thing. Alright, that looks good. So, do I have everything I need? I got the poles, I got how big they are, so yeah, let's put it together. So I have every 60 degrees in each quadrant and the main axes, right? No, 0, pi over 3, 2 pi over 3, and pi. Let's do those first. So now I'm going to be graphing my tangents at the pole. So one is at 0. Pi over 3. Pi over 3, and pi. Let's see what else we had here. 4 pi over 3, 5 pi over 3, and 2 pi. So 4 pi over 3, 6 degrees in each quadrant, basically. And 2 pi we already got, as the same as 0. Let me label those real quick, just to be. Oops, theta, it does equal theta, but right now theta equals 0 or theta. Oh great, somebody's ruining my video for the phone call. Sorry about that. You guys are going to have to deal with the phone call. Should have put it on silent. Alright, so now what we do is we gotta start plotting the rose petals. So where were those located? Those were at 30 degrees in each quadrant, and the top 2 quadrants, and then 3 pi over 2. Okay, so 30 degrees, we'll do U in orange. I think that'll contrast nicely. And I go out, what was the radius? 4, right? So 30 degrees, 1, 2, 3, 4 draw a point there, and then the tangents at the pole tell me how big it's going to be. So there's my first rose petal. And then if we do same thing at 2 pi over 3, 1, 4, draw it, draw your petal, and finally at 4 and 3 pi over 2, draw your petal, and then there's your rose petal. I thought it was going to be a nice easy fill, but apparently it's going to take a little time. So let's recap. What did we do? We set it equal to 4, which was the maximum radius. Whatever the coefficient is, it's always going to be the maximum radius. And then after we set it equal to 4, we found those angles. If we hadn't found all 3 of the petals, we would have set it equal to -4. Then we found the tangents at the pole. Don't forget, whatever the coefficient is, that's how many times you're going to have to go around the unit circle. So in this case, we had to go 3 times around. And then don't forget to divide by the 3, the coefficient. And then plot, and you're done. Alright? Practice these. They can get a little tricky if you don't do them enough. They seem kind of easy at first, but they get easier after you do a few of them. So I hope I've cleared up any confusion. Thank you and have a nice day.